3-minute thesis, Cornell University, 2018. Mengran Wang, 3-photon microscopy, seeing deeper inside the brain.
The brain is one of our most important and complex organs. Do you know that there are 100 billion neurons in our brain? This is the same number as the stars in the Milky Way galaxy. Besides, each neuron has 10,000 connections to other neurons, which means we have much more connections or synapses in our brain than there are stars in the universe. Imagine all this content in such a small space, something I can literally hold in my hands. In fact, in a moment just like this, trillions of synapses in your brain have just fired to process the information I was telling you. Apparently, the brain is complicated, and the current understanding of how our brain works is very limited. There are many brain diseases, such as Alzheimer's, which affects 1 in 10 people over 65. We don't know how to cure them, and we can't even give an accurate diagnosis. So, if we want to study the brain and not cut it open, what should we do? Light microscopy is a method which can allow us to see small structures in detail. However, the challenge of the conventional light microscopy method is that when we want to look deep into the brain, the images become very blurry. So, to solve this problem, my research group invented a new tool called 3-photon microscopy. The advantage of this tool is that the images are now much more clear, and we are able to see much deeper into the brain. Imagine you are looking for your friends in a crowd of people. They look similar, they dress the same way, and are all crammed together. Even if they jump or wave, you still can't see them. It's like where's Waddle? So what should you do? You don't poke inside the crowd and look for your friends one by one. But you can try to find a way to make them stand up to you. How might we do that? One way is that we can make them stand on each other's shoulders so we can find them immediately. This is essentially what we do in 3-photon microscopy. We don't try hard to look for the signal out of the background. Instead, we use 3 photons to light up what we want to see so that the signal can stand out itself. In this way, the signal is much brighter than the background, and we can get much more clear images. As you can see in this image, which was created by 3-photon microscopy method. I believe in the near future, by using this technology, we will have a better understanding of the brain areas which we were unable to study before, and have a better weapon to fight brain diseases such as Alzheimer's and clear the pain away. Thank you.